Question 16 says, which of the following expressions is equivalent to x raised to the 2/3 power? And as answer choices, we have a bunch of expressions involving the letter x, as well as different operations on the 2 and the 3 from the prompt as well. Another thing I'm noticing about these answers is that answer choice H and K are kind of opposites in the sense that when a square root is written, there's implied to be a 2 right there. And so H has the 2 there and then the 3 there. And then K kind of has flipped those numbers, but otherwise these answers are the same. So I'm just going to write opposite here. Seeing these things among the answers is going to be helpful for a couple of reasons. The first is that if we decide to solve this question in a formal way, then we know to be extra careful about the position and the operation of the numbers that we're using here, because it seems like, at least for H and K, they're trying to catch us on a small little mix-up there. And the other huge takeaway, and I would say this is really the biggest thing to take away from looking at these answers, is, again, the fact that the letter X appears not only in the prompt, but in each of the answer choices. And the reason why it's so important that we notice that is because when a question is structured in that way, where it has a variable in the prompt and in each of the answer choices, then almost always the question can be solved through the technique of giving ourselves an example. And that's where we choose an arbitrary value for X. It could be whatever value we want, and we just plug it in, and we solve the question entirely through the example that we gave. It's a really powerful technique that can be used for a lot of different questions. So we want to get used to noticing questions that can be solved in that way. So I'm going to write out the different ways we can solve this. We'll start out with the concrete way, which is to give ourselves an example. Give yourself an example, and then we'll do it the formal way using knowledge of fractional exponents. And by the way, if you know fractional exponents, this question is super straightforward. You will know that to rewrite this, you just raise the base to the numerator, and then you take the root of the denominator, which basically is answer choice K. So it's immediately solvable in that sense. Even if you do know that, though, I would stick around and see how we solve this concretely, because we'll see here that we can still get this question right with literally no understanding of fractional exponents. So it's a great demonstration of how being flexible with our problem solving can allow us to either double check our sort of formal knowledge or sort of bypass it if we are rusty with the material or we just have never learned it before. To use the technique of giving ourselves an example, essentially what we're going to do is just choose some random value for X here, and we're going to plug in that new value in any time that we see the letter X. And we can really choose any number that we want, especially in this question here, because there's no restriction on X. Sometimes they'll say what is equivalent to blah when X is greater than 3 or something, in which case you have to choose a number greater than 3. But there is no restriction that's talked about in this prompt. That being said, I usually avoid using numbers like 0, 1, or 2, just because a lot of times more than one answer will end up working for those particular numbers, and it just makes the whole process a little bit more tedious. So let's choose a number like 5, for example. That should be fine to use. And essentially what we're going to do now is, now that we've chosen that number, we're going to plug in that number anytime we see X in the prompt and in the answer choices. So essentially the question is now asking which of the following is equivalent to 5, because we're replacing that, raised to the 2/3 power, like that. And then I'm just going to rewrite this too so it's a little clearer there. Okay. And then answer choice F is going to be rewritten as 5 squared divided by 3. And then answer choice G, we're going to replace that X with a 5 as well. So it'll be 5 times 2 divided by 3. Answer choice H is going to be the square root of 5 cubed. And then answer choice J is going to be the cube root of 5. And then finally for K, that's going to be the cube root of 5 squared, like that. So now that we've rewritten all the answers and the question like this, let's just go back to what it's asking. Which of the following expressions is equivalent to 5 raised to the 2/3 power? And then again, we have all these different options here. The question now is, how do we figure out which of these different answers is equal to 5 raised to the 2/3 power? They're all involving 5 and 2 and 3. Well, basically what we can do at this point is just remember that we have our calculator and we can plug in that number that we chose, 5 raised to the 2/3, and get a sense of what the actual value of that number is. So 5 raised to the 2/3, and it looks like 2.924 approximately. So I'll write that right here. This is approximately 2.924. Now let's look at each of these answer choices and see what they are equal to. So answer choice F is 5 squared divided by 3. So 5 squared divided by 3, and that gives us 8.33. So equals 8.33, which is not going to be our answer. Answer choice G is 5 times 2 divided by 3. 5 times 2 divided by 3, and that is 3.33, repeating. And once again, that does not match up with the 2.924 that we're looking for. Answer choice H is the square root of 5 cubed. So we'll do square root 5 cubed, and that is 11.18 approximately. 11.18, and that is, again, not what we want. Answer choice J is the cube root of 5, so let's check that. And a lot of students won't be super familiar with how to get a cube root on their calculator. If you have a TI-84, you can do math, and then it's number 4 here. It's like a little cube root symbol, and most calculators will have some cube root option. So you can do the cube root of 5, and that is 1.71 approximately. So 1.71, which again isn't the 2.924 we wanted. At this point, it seems like the answer will be K since all these others don't work. However, it's not a good idea in general to just circle an answer at this point just because the others don't work, because it's possible that we could have made a small mistake in calculating one of these. And so the best way to prevent against that is just to put this into our calculator, make sure that it does in fact match up with our original answer. So let's again do the cube root of 5 squared. Cube root 5 squared. And that gives us the 2.924 that we had originally got. So this works and it matches up with our original question. And as I mentioned earlier, we literally could have chosen any number in the beginning. We just chose 5, but a great exercise to get more comfortable with this technique of giving yourself an example would be to choose another number here and just sort of prove it to yourself that no matter what number we choose, answer choice K, when we plug it into our calculator, will always give us the same value as the original expression here. Now that we have solved this in the more concrete way of giving ourselves an example, let's review the more formal way of solving this, which is to use an understanding of fractional exponents. A fractional exponent is exactly how it sounds. It's just an exponent that involves a fraction. And what we want to know about fractional exponents, I'll write it out right here. Basically what we do is we raise the base to the numerator of the fraction, and we're going to then root the base by the denominator of the fraction. And so what that means, for example, in this particular context, is that the numerator of this fraction is 2. So we're going to, and the base is obviously x, so we're going to raise x to the second power. And then the next step is to root the base by the denominator of the fraction. So the denominator of this fraction is 3. So we're going to take that third root of this expression right here. So it becomes the cube root of x squared, which matches up with what we got in the concrete approach, answer choice K. And in solving it in this more formal way, these wrong answers also begin to make more sense. Essentially, the wrong answers are anticipating mistakes in the application of fractional exponents. So for example, answer choice F correctly applies the numerator part, but then rather than taking the cube root of 3, it just divides by 3. Answer choice G kind of makes a couple mistakes here. Again, instead of applying the numerator as an exponent, it multiplies by that, and then it has the same mistake as F in dividing by the number 3. Answer choice H is kind of tricky in that, as we saw earlier in the answer previews, it's the opposite of K, so it's predicting that somebody messes up the application and just swaps the order of the numbers 3 and 2. And then answer choice J seems to apply the 3 correctly, but then drops the 2 for some reason. All right, so now that we have solved this question in a couple of different ways, let's think about like what we ultimately really needed to know for this question mathematically. If it occurred to us in the beginning that we could just plug in a number for x, then it was completely possible to solve this question with literally no knowledge of fractional exponents whatsoever. All we needed to be able to do was plug these different expressions into our calculator and see which were equal to one another. That said, obviously, if we are familiar with how fractional exponents work, the question can be solved in really just a matter of a few seconds. As always, though, I just want to sort of model how we can navigate a question, even if we're not 100% with the material, because I've seen so many students in the beginning just kind of look at questions like these and sort of feel stuck because they feel like if they don't remember the material exactly, then they basically can't get the question right, where if only it just occurred to them to plug in a number or something, it would be very easily solvable for them. And on that note, I would say that the biggest sort of takeaways from this question, as always, we want to just look at how and why the ACT designed the question in the way it did. So this sort of ties back the fact that in this question, they gave us a variable to work with rather than a number. If instead of giving us a variable from the very beginning, they just said which of the following expressions is equivalent to 5 raised to the 2/3 power, a lot more people would get this question right because they would just use their calculator like we did to solve the question. And so the ACT doesn't make it easy for us. Instead of giving us a number, they use this element of abstraction to make questions hard. And we'll see that again and again among these questions, this principle of trying to make things abstract, less concrete. And so one of our most powerful tools on this test is to throw it back at the ACT kind of and make things visual, make things concrete, and easier to work with. And that pretty much wraps things up for this question. So let's go ahead and go on to question 17.